Right. In this video, I want to talk about one-step equations, which is the building blocks of, all the algebra equations and various math classes beyond that. So one-step equations are based off of four properties of equalities, right? And the first property is the addition property of equality. The next property is the subtraction property. All right, so what this means is this: if we had an equation such as this or this, okay? So we have two separate equations. What we need to do is we need to move the number to the other side of the equal sign. And to do that, we use this property. But we do opposite of whatever the number is. So what is the opposite of a positive 3? It's negative 3. So in this case, for this problem, we're going to subtract 3 from both sides. And then that would give us a solution of x equaling to 7. All right. Now, if we took a different equation, such as this, what do we do with this number? We do opposite of whatever it says. So in this case, if it's negative 3, the opposite is positive 3. And then we would get x equaling to 13. So in math terms, again, these are the addition and subtraction properties of equality. To keep things simple, I just call it do opposite of the number, okay? So whatever the number is, we just do opposite of it. And when we do opposite of it, it goes across the equal sign. All right, now, typically these two steps are done first in one-step equations and also in multi-step equations. Most times. There are some exceptions, but this is one of the first steps that you'll do. All right, now there are two other properties. You can probably guess. One is multiplication and one is division. All right, so what if we had the example of this? 3x is equal to 12, okay? So now in this case, what are we doing to x? Because the name of the game in equation solving is we want the variable by itself on one side and then all the numbers, the non-variables, on the other. So in this case, we're multiplying x by 3. So what is the opposite of that? We're going to do divide. So if we're multiplying x by 3, we're going to divide both sides by 3. And then we would get x is equal to 4. Okay, so ask yourself, what are we doing to the variable? We're multiplying it by 3. And then what is the opposite of that? We're going to divide. Okay? All right, now what happens if we get something like this? Okay? So what are we doing to 4 in this case? We're dividing it, what are we doing to x? We're dividing it by 4, right? So how do we undo divide by 4? We multiply both sides by 4, and when we do that, this cancels out because it becomes 4 over 1 times 1 over 4, and when you multiply the reciprocals, they equal to 1. Over here, this would give us 12, so our answer would end up being x equals to 12. Okay, so this is the case where a fraction, where the numerator is actually 1. We'll talk about a special case in a minute where that's not going to happen, and we can do two different ways for those types of problems. All right, so once you understand that, in those two examples that I just gave you here, I call that do opposite of the variable. Okay, so whatever's happening to the variable, we're going to do opposite of whatever's happening to that variable. Okay? All right, so now let's talk about this, expressions versus equations, because there's a difference. Right, so here would be an example of an expression, 4x plus 10. Okay, here's an example of an equation, 4x plus 10 is equal to 2. All right, what's the difference between those two? An equation has the equal sign. An expression does not. Okay, an expression does not. Equations we solve, and expressions we simplify. Okay, and we use basic properties of math using PEMDAS and so on to simplify expressions, and then we use our algebraic properties to solve equations, like these properties up here. Okay. All right, so here's some vocab for you. So variable, in both of these things, the variable is going to be the letter, and the variable is a term that can change, that changes over time. It can be modified. right? We can make x any number we want. And when we do that, the output is going to be a specific number, okay? All right, a constant in these examples are going to be tens, okay? And technically this would be a constant too because it's not changing, right? We're adding 10 to whatever happens to 4x. And then we have, it's going to equal to 2. That's not really changing either, okay? All right, and the last thing is the coefficient. So in this case, the 4 in front of the x is going to be the coefficient. So whatever number is in front of the variable is the coefficient, okay? So keep that in mind as we use vocab terms that we understand what's going on, understand the difference between expressions and equations, okay? All right, now here's some special cases. What if we get an example of this? 4 pi minus 2 pi is equal to 6 or something like that, okay? How would you solve that? Well, consider pi as a variable, okay? Consider pi as a variable in this case. So what would happen in this case? It would be 4 pi minus 2 pi, which would give you another 2 pi, and then that would equal to 6, and you could solve it from there if you wanted to. Okay, so if you ever run into pi's and they're combined like this with the coefficient and pi is a number, but treat it like a variable in how it behaves in the equation. Okay? All right, here's the one exception I want to talk about. What happens if we get 3 over 4x is equal to 8? Okay, what do we do in this case? Well, what are we doing? So if we use our do opposite of the variable rule, what are we doing to x in this problem? We're multiplying it by 3 over 4. So how do we undo that? We would multiply it by 4 over 3. So one way to solve this in the one-step manner is to multiply this thing by 4 over 3. So these would cancel out, and when they cancel out, it's because they equal to 1. Okay, so 4 times 3 is 12, 3 times 4 is 12. 12 over 12 is 1. So then x would equal to 32 thirds. Okay, that would be using the one-step way. Now, there is a different way to do this. What happens if we have it written like this? Okay, and this will get into the two-step method of solving equations. So this one can be solved using one step. It can also be solved using 2 steps. So this will be a preview of what's coming up in the next lessons. All right, so what we would want to do first is multiply and get rid of the fraction. Right, so when we do that, we get 3x is equal to 32. Okay, now this is the one-step equation, and we're going to do opposite of the variable. So whatever we're doing to x, we're going to undo that. So in this case, we're multiplying it by 3. Now we're going to divide it by 3. Okay, and then we get the same answer. Now, is one way correct and one way not? No, they both work. Okay, so I just want to show you using different properties that you can do problems differently, but this is an exception. And these are exceptions because the numerator is not 1. If the numerator was 1, we would just multiply it by the inverse and so on, okay? All right, so hopefully this clears up some questions about solving basic one-step equations.